Hello students, welcome back to SNEHA SOBTI YouTube channel, and again we have come with the topic of hybridization trick 2. The hybridization trick 1 I have already done before, whose link I shall provide in the description box, and that hybridization was of organic compounds. Today we shall be doing the hybridization trick for the inorganic compounds. All those who are new to my channel, kindly subscribe to my channel. My name is SNEHA SOBTI, and quickly subscribe to my channel, and the link I shall provide in the description box so that you can easily access my videos related to the chemistry subject content from grade 9 to 12 plus the competitive point as well. These videos are applicable for CBSE, ICSE, IGCSE, IB curriculum, so it is easier for the students to grab up the concept. So without wasting much time, we shall move on. Now, I've already explained what is hybridization in my previous video. Kindly, again I say, check up the description box. The link is provided. Now, hybridization trick, I write down 2 here for the inorganic compounds like nitrate, and multiple examples will be given to you. First of all, I'm providing you a trick, a formula to be used, which you are not supposed to be used in your subjective papers. It's just a trick how in a couple of seconds you will be able to find the hybridization of inorganic compound or radicals. Please watch the video till the end so that you can gain the maximum output from this video. Now, hybridization I'm representing with this H. And do remember, hybridization is always calculated for the central atom. Whichever atom is the central atom in that particular compound, hybridization is calculated for that central atom. The formula is half V plus X minus C plus A. Now, what does V stands for? X, C and A. V stands for number of valence shell electrons, or you can say the number of valence electrons. The valence electrons are the electrons which are present in the outermost shell. And these number of valence electrons you have to check for the central atom. Do not just check for all the atoms. It is the central atom for whose valence electrons you all have to check. What is X? X is the number of monovalent atom attached. Now, what does monovalent means? Mono means one and valency means, valent means valency. All those atoms or elements which have a valency of 1, they are called monovalent. That means if they are divalent, trivalent, you need not to add them or subtract. You only have to check for the number of monovalents. C is the cation, the charge which is there on a cation. Cations are positively charged. And A is the charge on an anion. You have to see the charge, and anion means a negative charge. Children, you remember this formula, and I bet you that you will not be defeated in any of your hybridization questions. This trick will be very useful for all the MCQs and to check whether my answer is correct or not. Just a quick recap. If the hybridization number is 2, the hybridization is sp. If the hybridization number comes out to be 3, then the hybridization is sp2. The hybridization number 4, then the hybridization is sp3. It comes out to be 5, it is sp3d. If the hybridization number comes out to be 6, it is sp3d2, and in some we write as d2sp3. Hybridization number 7, sp3d3. So basically this you have to remember. Now we quickly move on to some interesting questions and tremendous examples. So I again request you to watch the video till the end. So I give you an example. If I have to find the hybridization of ammonia with the trick is half V plus X. The central atom is nitrogen here. Nitrogen atomic number is 7. So the configuration is 2, 5. The valence shell electrons are 5. So V plus the number of monovalent. Hydrogen is monovalent. Its valency is 1. So how many monovalent attached? 3. There is no plus sign or a minus sign over. 5 plus 3, 8. By 2 is 4. So if the hybridization number is 4, then the hybridization is sp3. You can go on to the pause and previous. You can rewind it so that you can see the number is 4. Hybridization is sp3. We take up more examples. H2O, a very interesting and an important example. Here the central atom is, what is the central atom? O, because hydrogen, 2 atoms of hydrogen are attached. So half. Oxygen atomic number is 8. So the configuration of oxygen will be 2, 6. So 6 valence electrons plus how many monovalent attached? 2. No charge. 8 by 2, 4. Hybridization is sp3. We move on to next, methane Ch4. Now this time carbon is the central atom. So hybridization technique, half. In the carbon, the number of valence electrons are 4 plus number of monovalent atoms attached, hydrogen 4. 4 plus 4, 8 by 2. That is 4. So the hybridization is sp3. I hope you all know how to write the electronic configuration. Carbon has atomic number 6. So the configuration is 2, 4. So the number of valence electrons are 4. Number of monovalent atoms attached is 4. Now we move on to another compound. For example, if I take CO2. Here the central atom is carbon. So half number of electrons in the valence shell 4. Now many of the children get confused and they will write +2 and finish it off. But remember this oxygen is divalent and in our formula it is half V plus X. We have to plus the monovalent. Here is no monovalent. So the number is 2. So the hybridization comes out to be sp. I hope this is clear to all of you. Now, if I move to another more examples like PCl5, phosphorus is atomic number 15. So the configuration is 2, 8, 5. So if I put the hybridization technique formula, central atom has 5 valence electrons. So 5 plus how many monovalent attached? Chlorine has a valency 1. So 5 monovalent attached. No charge. 10 by 2, 5. So if the hybridization number comes out to be 5, then the hybridization shall be sp3d. We move to some more complicated examples for the better understanding. If suppose we have to calculate the hybridization of Sf6, I shall give you numerous examples. Sulfur is the central atom. Sulfur atomic number is 16. So 6 electrons will be in the valence shell. How many monovalent attached? Fluorine is a monovalent. So 6. 12 by 2, 6. So the hybridization comes out to be sp3d2. We shall move on to Sf4. Sulfur again is a central atom. So half, 6 electrons in the valence shell plus number of monovalent attached, 4. So 10 by 2, 5. So the hybridization is sp3d. Now next example, IF7. Iodine is the central atom. Half. Iodine is in the 17th group. Or you can say 7A group. So if it in the periodic table, it is in the 17th group or a 7A group, the group number tells you the number of electrons in the valence shell. If you do not remember the atomic number of iodine, you can just check in which group does it lie. The group number tells you the valence electrons. So iodine has 7 electrons plus the number of monovalent attached is also 7. So 14 by 2 is 7. So the hybridization will be sp3d3. Now we move on to some more complicated ones. Like if we have XeOF4. In this, the central atom is xenon. Xenon is in the 18th group, normal gas group. They have 8 electrons in the valence shell. Now, this central atom is xenon. Oxygen is divalent. So we will not consider it. We have to see only the monovalent. So plus 4, 8 plus 4, 12 by 2, 6. So the hybridization comes out to be sp3d2. Now, if I move on to XeO3, oxygen is a divalent. Central atom, xenon. 8 electrons in the valence shell, close the bracket, because this oxygen is a divalent. So 8 by 2, that is 4. So the hybridization will be sp3. We move on to more examples like this. Now, if we take up, suppose, XeO2F2, half. Xenon is the central atom. 8 electrons in the valence shell. Oxygen is divalent, so we will not consider it. Monovalent fluorine, 2 atoms of fluorine, 10 by 2, 5. sp3d hybridization. Now, these all examples which I have given you, they were of without charge. Now, let's do some examples in which charges are accompanied with a particular radical, like ammonium ion. Central atom is nitrogen. You can pause the video, rewind it, and see what was the formula again. Half nitrogen, central atom, 5 electrons in the valence shell, plus monovalent 4, minus the charge on a cation. It's a +1. So you have to minus the charge on a cation. Minus and just write down the number. So 5 plus 4, 9 minus 1, 8 by 2, 4. So the hybridization is sp3. If I take for nitrate ion, NO3 minus 1, same, half. Nitrogen central atom, 5 electrons in the valence shell. No monovalent, because oxygen is a divalent. There is no cation. Whenever there is an anion, a negative charge, we have to add that charge. So 6 by 2 is 3. So the hybridization is sp2. Just look on to the formula which I have already explained if there's any confusion. If I write down for carbonate ion, CO3 minus 2. So the hybridization is half V. Carbon has 4 electrons in its valence shell, plus I can even write 0. Why 0? Because oxygen is divalent, so we are not supposed to add it. And the charge on it is minus. So plus 2. 4 by 2, 6 by 2, it's 3. So the hybridization is sp3. Now we move on to more examples. Suppose hydronium ion, H3O positive. So half, oxygen is the central atom, 6 electrons in the valence shell, number of monovalent atoms 3, and the charge +1. So subtract it, because I write down the formula again here if you don't want to go back. Half plus X minus the charge on cation plus the charge on an ion. So it will be 9 minus 1, 8 by 2, 4. It's sp3. Shall we take up one more example? This is one of the example which has come up in JEE. That is I3 minus 1. This I3 minus 1, please write it down as I dot I2 minus 1. Now it's a simple half. Iodine here is the central atom, so 7 plus number of monovalent atoms 2, charge on an anion is 1, so we have to add it. So it comes out to be 10 by 2, 5. So the hybridization is sp3d. This particular question was a little bit tricky, but if you know the trick, you can easily do it. Now, children, I hope it's clear with all of you, and I give you some questions for you. You can do it. Any doubt, please do mention in the comment box, and you're most welcome to come up with your doubts. Sulfate radical you can try out. You can even try out for a carbonate ion. Then it's Sf4. You can even try it out for nitrite ion, and some which we have already done as XeO2F2. Children, any confusion to you, any doubt to you, please mention in the comment box. And thank you for watching my video. And please subscribe my channel if you're new to it. And do not forget to share and like, and do give the positive comments for it if you have understood this particular topic. Thank you so much. Have a happy learning.